Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to talk about horizontal stress. In our last video, we learned what is the meaning of soil vertical stress and how to calculate it. In this video, we are going to discuss the soil horizontal stress. If we want to excavate a vertical trench in a soil, it makes sense that you need to build a retaining wall or any supporting system to hold the soil from collapsing. The retaining wall will be under the effect of horizontal stress coming from the soil. Horizontal stress at soil is also in a shape of triangle, and it increases as we go deeper because it depends on the vertical stress. And we have learned earlier the vertical stress increases as we go deeper. The horizontal stress at any point equals to the vertical stress multiplied by the coefficient, which is called either active pressure coefficient or passive pressure coefficient. The pressure coefficient is active in the side where the soil is trying to move the structure, while the pressure coefficient shall be passive in the side where the soil is resisting the movement. The active and passive coefficients could be calculated using those equations. K active equals tan squared to 45 minus phi over 2, and K passive equals tan squared to 45 plus phi over 2. In vertical stress calculations, we learned that the only effect of water pore pressure is reducing the weight of the soil, which reduces the stress on the layer below. However, in horizontal stresses, the water actually is applying horizontal pressure on the retaining wall, and it equals to the same value of gamma h like we learned in vertical stress. As we can see here, the vertical stress at this layer will equal to gamma 1 multiplied by h1, and at this layer will equal to gamma 1 multiplied by h1 plus gamma 2 multiplied by h2 minus the pore water pressure, which is gamma water multiplied by h2. So this would be the effective vertical stress. In addition to effective vertical stress, we have the pore water pressure, which equals to gamma water multiplied by h2. But this is the value of the pressure. So what is the value of the force here? The value of the force will equal to this pressure multiplied by the area of this triangle. And this will give us the force per unit length. So in order to calculate Pw, which is the force due to the water pressure, it will be the area of this triangle. And we know that the value here is gamma water H2, so the area of this triangle, it will be gamma water H2 multiplied by H2 multiplied by half, because this is an area of triangle. So this is it, half gamma water H2 squared. The effective horizontal pressure will be calculated as we have explained earlier. So the value of the horizontal pressure here will equal to sigma, which is the effective vertical stress, multiplied by K, which is the active pressure coefficient. So if we know now that the value of the pressure here equals to sigma 1 multiplied by K, and we want to calculate the force, and it will be the area of this triangle. So the area of this triangle, it will be sigma 1 K multiplied by half H1, and the same will be done also here. This might seem confusing now, but it will be very easy once we start solving examples. So let's check this example. We have a retaining wall of 12 feet high, and the backfilling behind this retaining wall is 120 pounds per cubic foot. It is saturated 5 feet below the top level, and the angle of internal friction is 30. We want to calculate the resultant of the active lateral force behind the wall. So first step, let's calculate the K active, which equals tan squared 45 minus phi over 2, and here phi equals 30, so this will be tan squared 45 minus 30 over 2 will equal 0.33. Second step, we will start drawing our horizontal pressure behind the wall. It will look like this. We have here P active 1 and here P active 2. P active 1 will stop at the level of the water, and P active 2 is the total at the bottom of the 12 feet. And of course we have the triangle for the P water, the horizontal pressure of the water. We will start first by calculating P active 1. P active 1 will equal to the gamma multiplied by K by H, which is 120 multiplied by 0.33 multiplied by 5, which will equal to 200 PSF, and P2 will equal P1 in addition to the gamma KH for the 7 feet part, which will be 200 plus 57.6, because this is 120 minus 62.4, because this gamma is the effective gamma. So it will be 57.6 multiplied by 0.33 multiplied by 7, which will equal 333 pound per square foot. And P water, which will equal gamma water multiplied by H, which will be 62.4 multiplied by 7, will equal to 433 pound per square foot. Now we will calculate the F, which is the total force behind this wall. And to calculate F, we will just calculate the area of this pressure shape, which is the triangle for P1, the triangle for P2 in addition to this rectangle. So it will equal the 200 multiplied by 5 multiplied by 0.5, which is the triangle for P1, in addition to 200 multiplied by 7, which is this rectangle under the P1, in addition to 133 multiplied by 7 multiplied by 0.5, which is the P2. And here in P2 you can see we took only 133, not the 333, because the 200 is in shape of rectangle and the 133 is the triangle. So it's 133 multiplied by 7 multiplied by 0.5, in addition to the triangle for the water, which is 436 multiplied by 7 by 0.5. So this will come to a total of 3,890 pound per foot. So this is the answer. The closest answer is B, which is 3,880 pound.